Good afternoon, everybody. Welcome to Marposs webinar for leak testing, where we will present test solutions we have available for different components of battery systems. Here at Marposs, we like to say that Marposs is the global answer to your quality control requirements. One partner, many solutions. Hopefully at the end of the webinar, you'll feel the same way. So our world headquarters are located in Bentivoglio, which is a suburb of Bologna in northern Italy. We have 80 offices in 34 countries around the world, and Marposs reached a consolidated turnover of more than 500 million US dollars with 3,500 employees worldwide. More than 90% of turnover is obtained through export, with more than 26 production companies in the group offering various technologies. So on the bottom left, you see how the workforce is distributed. And a very important point is the 8% reinvestment of our turnover annually into R&D, which is especially important now considering how fast things are changing. Our customer base varies from different industries, including automotive, of course, aerospace, appliance or white industries, of course, OEM partners, medical, and now battery and EV manufacturers. The different technologies the Marposs Group offers include contact and non-contact gauging, machine tool and process monitoring, as well as automation and of course, leak testing. But before we look at different leak test systems we have to offer, we'd like to mention some of the other important technologies we have, specifically some of our non-contact inspection solutions for battery production. So the upper photo is our electrode expansion test bench, which measures the expansion and contraction of a battery cell during charge and discharge cycles. It's a lab type bench which helps characterize the behavior of electrodes for new battery cells. And then we have a product line of non-contact gauging and inspection for the roll-to-roll process, the R2R roll-to-roll process, which include an inline width measurement application using the Marposs AeroL laser scanning micrometer. And AeroL is a company recently acquired, part of the Marposs Group, and also a non-contact roll-to-roll film and coating thickness measurement system, which uses confocal technology. And the bottom picture is another example of a non-contact system for inspection of welds on a pouch type battery cell, which uses interferometer sensors. So Marposs offers a wide range of solutions for testing battery systems, which include leak testing applications along the complete manufacturing chain, which will be the focus of this webinar. Electrical testing of battery cells for beginning a line testing in module assembly lines or cell sorting lines, and then end of line electrical testing of battery cells, modules, and packs. Now, if you're familiar with Marposs, you know us as metrology experts, so with over 60 years of experience engaging in machine monitoring. But over the past 20 years, Marposs has made some important acquisitions that give us more than 50 years of combined experience in different leak testing technologies. So we have 4 major production centers where the focus is on leak testing, which includes at the top M&A or Marposs Nanjing, which is a production facility close to Shanghai in China, with over 700 employees, more than 320,000 square feet of manufacturing space, and their focus is on Chinese and Asian markets. As a side note, they offer local production for all kinds of Marposs leak test solutions that we'll be talking about. Second picture is a company called Tech or Helium Technologies, located outside of Milan in Italy with over 60 employees and more than 15,000 square feet of manufacturing. Their focus is hard vacuum leak testing using helium as trace gas. MG, another company acquired by Marposs, more than 125,000 square feet of manufacturing. And they have a really wide range of applications in their portfolio, which include engine components, cylinder head, cylinder block, transmission components, assemblies, housings, and they use both air and trace gas. And there's been a recent particular focus on batteries, modules, trays, packs, the battery pack components. And also in recent years, they've integrated a French company called Trace into their production facility. Trace was acquired by Marposs in 2006, and they have over 20 years of experience with trace gas applications, so hence the name Trace. And then finally, at the bottom is a company called Techna. They're a very strong instrument manufacturer located in the heart of Europe's biomedical district in northern Italy. They have more than 30 years of leak testing experience. So the traction battery is the core element of the electric vehicle. In order to meet high quality requirements of batteries for both stationary and mobile use, measurement and testing technologies must be systematically applied in the production of the individual components that go into the assembly and the entire assembly, as a matter of fact. First, to avoid rejects, and second, to meet the safety and performance requirements. So leak testing is a crucial component of the manufacturing process of battery systems, and consequently needs special attention along the entire production chain. And the individual components we're focused on are the cooling plates, the battery modules itself, or the battery cell itself after the electrodes have been assembled. The modules, which really don't require a lot of leak testing, but there's a lot of end-line electrical testing that we can do. And then, of course, there's the battery pack assembly and the individual components that go up into making the battery pack, specifically the tray and cover. And the tray is the structural component of the battery. So we have applications in the field for all those components. Marposs offers different testing solutions and technologies. And this is just a picture of one of the very first leak test systems they developed for battery cells. More of a transition slide, just to talk again, or to mention again that where you want to look at the entire process from the battery pack assembly to all of the individual components that go into the assembly, the battery cells, the trays, the covers, the cooling plates, and we have different technologies depending on the individual requirements. So, but before we look at the leak testing, I want to take another quick look at some additional technologies available in the group. For example, to monitor the stamping process, which could be used in the production of cylindrical cells. So starting with the housing, which is a drawn part from a blank, can be cold formed. We have sensors available like acoustic positioning and force monitoring sensors to help control the stamping process, which can help prevent those defects like cracks, which can become pathways for leaks. These types of sensors can also be used on a prismatic battery, and they're available from a company called Brandcamp. It's a German company acquired a few years ago by Marposs, part of the group. Always looking to control the process We also have, Marposs has a complete line of eddy current cells. It's non-contact, non-destructive testing for cracks, pores, those defects that eventually turn into pathways for leaks. Something you want to eliminate, especially with batteries. So now this is a simple schematic of a hard vacuum application, showing a prismatic battery cell after the electrodes are assembled, but before it's filled with electrolyte and before it's sealed. In this specific application, an opening is available to charge the cell with helium and test for leaks in a hard vacuum. So you'll load the cell into a chamber, attach a helium fill source to it, close the chamber door, pull a vacuum, and after it's charged, if there's a leak, helium will flow out of the component, and a mass spectrometer will detect that flow. So these typical leak rates are in the range of 10 to minus 5 or 10 to the minus 7 cubic centimeters per second, which is a pretty tight leak rate, and that requires hard vacuum trace gas inspection. This is another schematic, same part, but this manufacturer chose to fill the electrolyte and helium. So they charge the part with a little bit of helium. When they charge it with electrolyte, they seal it. So the part's sealed with helium. So the simplest thing you can do is put it into a vacuum chamber, pull a vacuum, and if there's a leak, that helium that's been charged in it will find its way out, and a mass spec will detect that leak. So keeping the last two slides in mind, this is an actual heat tech system in the field that uses hard vacuum with trace gas to detect leaks in the battery cells, again, before the cells are filled with electrolyte. But this particular station checks 8 cells simultaneously. It's a double chamber, so the fixture that you see will advance to the left, and you can see a little bit of the chamber opening. And as that advances to the left, the second fixture, you can see this is the second chamber, will present itself, so it can be loaded with, or you unload the tested cells and load with cells to be tested while chamber 1 is working. So this is, of course, a global test. And if one cell is bad, the entire cycle is rejected. But you have the option to run what we call a hybrid cycle. So if you have if you run a cycle and you have a good result, obviously you pull all 8 battery cells out. If you have a reject cycle, you can run a hybrid cycle, and it'll test the individual cells one at a time to tell you which one of the cells, or how many of the cells were actually rejected. So Marposs now has developed a station for leak testing of button type battery cells. This is a little bit more advanced than the first picture you saw back at the beginning here, but the button cells are the small batteries that look like coins. Of course, they're sealed, and they go in watches or calculators or stuff like that. And this particular machine has a high throughput as it inspects 12 cells at a time and gives a machine takt time of 1 second. So this is a relatively new development. It uses technology that really isn't out there. And if there's anybody in the audience that has an interest in checking sealed battery cells, let us know, and we can study specific requirements for your application. So this is solution here, we show two solutions. Actually, the picture is a simple trace gas solution for cooling plates. We call it a clamshell machine, which has a manual door here. An operator will close, has balancers and a cylinder to make it a little lighter. But it's a vacuum chamber that where the cooling plate gets placed. It gets charged with the helium, and then we detect if there's a leak with a mass spec. So this vacuum chamber, you see the chamber itself has the forklift tube. So this system here can use different chambers. So most of the cost in these systems is with the pumping station and the mass spec and the controls and the HMI. Obviously, the chamber itself has some cost, but in this particular station, they can remove the chamber assembly and replace it with another chamber assembly for a similar part or a different part. And you're essentially reusing all of the important components of the machine, the mass spec, the pumping station, et cetera. Well, then here at the bottom is just a cooling plate with a Techna instrument attached to it, a little simpler application, low cost, and checking the cooling plate for leaks using mass flow, actually. So one of the technologies that we haven't mentioned is accumulation. So the global test for battery trays and battery packs are often requested just to minimize production time in an automated production line. So air methods can be used, and they usually ask us to guarantee an IP67 or IP68 seal with air, but accumulation method can guarantee a higher sensitivity. So we really don't give an IP rating. We just tell you whether the pack or component is leaking. So in this application, it's a completely automated line. A completed battery pack is tested using the accumulation method, where the assembly is automatically moved into the station and placed into a chamber. So it's not a vacuum chamber, but it's a chamber that's sealed from exposure to the ambient. The part is charged with helium, and of course, if there are any leaks, helium will flow out of the part and into the chamber, and will be detected with a mass spec that gets connected through a series of valves. So this method's also been used with the battery trays. That's before the tray is assembled. Obviously, it gives a global indication of the component. So oftentimes we're requested to localize leaks in a component or an assembly, specifically trays, because they're so big, they can't be thrown away. I mean, you don't trash a battery tray because it has a leak. So oftentimes we're asked to localize or find exactly where the leak is coming from. And we do that with the helium sniffing. So what we have here is a portable trolley, a very flexible solution that has both air and helium technologies available. So you see there's the Techna instrument on the shelf there that is used for global test to inspect the tray. And there's a mass spectrometer that's housed in you don't see it, but it's housed in the bottom of the trolley for the sniffing. And you see the fixture itself is for a battery tray. And this specific application is for a low volume prototype tray, which gives the user the possibility of checking the entire tray globally with the air. And if they find a reject, they just charge the the tray with helium and sniff to find the exact locations of the leak, and then send it to a repair station. This system uses a Marposs industrial PC with Marposs Quick SPC software, and we have a guided sequence program that guides the operator through the specific tests required. So it's pretty complicated because you have to load the tray, then you have to actuate these valve seals here, and then you have to connect it's fairly manual, so you have to connect your helium source or your air source and do your testing. Excuse me. So oftentimes we're also asked to do this in an automated setting. So what we do is this is a schematic. It's the 3D of an application where the battery tray is loaded onto a shuttle, and this tray will get shuttled in underneath this blue detail, and then gets lifted up and sealed and charged with helium. So in this specific application, we couldn't show the tray. So trust me, that's a tray. And in this application, the bottom side is down. So we're looking into the tray itself, and there's quite a bit of distance of length that each robot will sniff. So each robot end arm tooling has a sniffer, a helium sniffer, and also has like a magic marker on it, so that if you find a leak, that marker will indicate where the leak is coming from, so that it can be sent to repair. And then more sophisticated software has been developed so that we memorize where the leak is, and we store that data on the tray tag or the pallet tag or whatever, and if it's reject, it gets sent to a repair bay, and that tag is read, and an image is projected onto a large screen, and to indicate exactly where the leak was detected. And we have quite a few of these applications in the field. It's relatively new. We've been doing it for about 3.5, 4 years now. Every time we do one of these applications, we learn something new. So this happens to be a system that was manufactured in China for a battery tray, which you really don't see. The cycle time will determine the number of robots needed, but each robot has a sniffer on the end of it. And in this particular case, it's you really don't see. What you're looking at now is the tray. The tray is in there, and it's in the test position. So there's these systems are pretty large. Those trays are heavy, hard to manage. They move around a lot. They're like balloons when you charge them with air or helium, they're not easy to test. But testing with helium and sniffing is one of the better solutions that we've come up with. So I know we've shown the Techna instruments scattered throughout the presentation, and I said they provide a family of instruments strictly for air, no trace gas, but they have all kinds of instruments which cover pressure decay, or absolute or differential, mass flow, vacuum or flow testing. They're low cost and reliable solutions that we have to offer. And finally, this is an application where we're testing a battery pack. a completely assembled battery pack. And they are doing 2 tests. They do, so this battery pack has an integrated cooling system. So we check the cooling circuit by air. And then there are avenues to charge the internal volume with helium, and they do sniffing. They do sniffing to find those points that are leaking. So that's it. That's what I have. Thanks for your attention. If you have any questions, go ahead and ask. I hopefully agree that Marposs can be the global answer to your quality control requirements. So as the world moves to electrification, Marposs is moving too, and we hope somehow with all the different products we have to offer, you can join us. You're a global partner with many solutions. So again, thanks. And if you have any questions, I'll try and answer them.
Thanks, Dan. Yeah, we'll just give it a minute, see if any questions come in. But if not, oh, here we go. We have one. Do you build the leak testers in the US or only Europe?
We do both. So we have local production, but for the more complicated systems, they're built in Italy. Okay. Those big applications for trays, tray covers, they're all built in Italy.
What other industries and applications and types of leak testing should we be looking for leak test opportunities?
Well, you know, thankfully, everything leaks. There's nothing on this earth that does not leak. So one of the new fields that we're looking at are appliance manufacturers. I know there aren't a lot in the United States, but they tend to be coming back, and we're starting to look at them. Energy industry. Fuel cell manufacturers. Fuel cells have what's called the bipolar plates, and those are all need to be inspected. So a small fuel cell will have maybe 20 of these bipolar plates, and each of those plates needs to be tested. And generally, those are done with leak test. So are you offering any other leak test methods? Yeah, so we have both tracer gas, and we do test with air, pressure decay or mass flow. It depends on the application, depends on the test parameters. How long does it take to test a large battery cover or tray? Yeah, that's a good question. So obviously it depends on the size. It depends on the leak rates. Leak rates are all more or less on a battery tray anyways, and the covers. We're seeing that they're more or less in line regardless of the manufacturer. So the battery tray, just the test time can be up to a minute, because these are really large volumes. If you're talking about air, they're large volumes. The trays are like balloons. You can't charge them with a lot of, you can't put them under a lot of pressure, but you do have to charge them, and they're large surface area. They're like little heat sinks. So it depends. I mean, we have some applications that have, pressure decay or mass flow. They can run up to 120 to 180 seconds for the charging, testing. You charge, you stabilize, you test, and discharge. So stabilized time is eats up most of the test time. And the problem with the, generally in these, where the trays are produced, air technology isn't really the best approach, unless you can, you really control the ambient pretty good. We do a lot of accumulation testing on battery trays, but it's pretty maybe evenly split between accumulation and sniffing, because for the most part, the only way you're going to find a leak is when you're sniffing with helium or another trace gas. You're going to use a forming gas if you don't want to use helium. So.
Okay, if there's no other questions, oh, I just got one more. Does helium test day cover quicker than air?
Yes, in general, an accumulation test with helium is quicker than air. It's quicker, it's more sensitive, we think more reliable. Don't have to, it's easier to control. And there's the added cost of the helium, but there's, it's not really a lot of helium that you use. They're big volumes, but we don't, you can't evacuate 100% of the air from the tray when you test. So we pull a little vacuum and then fill it with helium to whatever, 50 millibar. And that results in about between 5 and 10% helium concentration. But we find the test is faster and more reliable. So it's the same complication as sealing, and these trays are big, they're heavy, they're the tolerances on them they're huge. They're not talking about microns, we're talking about millimeters. So.
Okay, there's a couple more. Are most leak systems turnkey?
So we do both. So Tecna is strictly instrument manufacturer. So we can provide just the instruments, then we do provide instruments to automation companies that build their own leak test systems. So, and on the other hand, we provide complete turnkey systems, regardless of the complexity. So we have automation capabilities. We have built simple manually actuated leak test systems to completely automated robot load. We provide the robot programming, the robot end arm tooling, load to a station, etc. How do you recover helium? So we build recovery systems, helium recovery systems. And then generally, the heat tech applications, those are strictly helium with hard vacuum. I think 95% of those systems are sold with a recovery station. So either the helium recovery station is integrated into the machine, or we have a family of recovery stations, depending on how much helium you need to recover, or how many stations you have to connect to. So we have different capacities. So yes, we recover the helium. We do it with, they're called recovery systems, helium recovery systems. How sustainable is helium testing? So that's a good question, because I spoke to someone at the Bureau of Land Management and BLM, and the government used to sell a majority of the helium in the United States through the Bureau of Land Management, that they have since sold off their helium reserves. So it's all privatized now. And I asked him specifically, well, why was it done? And is there a shortage? And he laughed, and he basically, he said he gets that question a lot, but he doesn't see a helium shortage for the next 100 years. There were some, I think last year there was a shortage because of some bureaucratic issues, but I think for the past, as long as I've been doing this question comes up when we running out of helium. And government told me they have at least 100 years of supply in the ground, so I don't see it happening anytime soon. And hopefully now that it's all privatized, the price is probably going to be a little bit more reasonable, but who knows? Richard, hey Richard, can we test coolant tubes for batteries or trays? Yes, we do. We have applications out there that test the tubes. Depends on what you're calling or what they look like, but and what the leak rates are. But we've done both the pressure decay and helium. So I don't know if those answers are okay.
Yeah. So we can wait a second, see if any more questions come through, but if not, then we'll just go ahead and end it, and the presentation will be available on our YouTube channel, and also Dan is available to take more questions if they arise afterwards.
Yeah, absolutely.
Yeah. So if we're all set, we can just go ahead and end it.
Okay, appreciate it. Thanks, everybody.
Yep, thanks for attending, everyone.
Hope it was helpful.